In this video, we will understand the basic concepts of another method of forecasting, which is exponential smoothing. In one of the previous videos, we have seen the weighted average method of forecasting. In that method, we saw that each period in the past was given a weight. So if we were going to forecast for, let's say, month number 4, what is the forecast? And if we had the available figures of sales for the previous 3 months, let's say month 3 the sales were 1000 units, month 2 the sales were 750, and month 1 the sales were 700. So in order to find the forecast for month number 4, we could take the weighted average of these 3 months sales data by giving a weight to each of this month. So we could have given a weight of 0.5 to the third month, 0.3 to the second month, and 0.2 to the first month. The condition is that the sum of all the weights should be equal to 1. Or, depending on our previous experience, we could have given the weights differently. So we could have given the weights as 0.5 for the third month, 0.4 for the second month, and 0.1 for the first month. The total, of course, should be 1. So this is in the case of weighted average method. Now in the exponential smoothing method, the forecast is again calculated as the weighted average of all the previous values, but it is based on the premise that the most recent value is the most important for predicting the future value. Also, the values prior to the current value are also relevant, but in declining importance, and the weights decline exponentially as we consider the older values. So in this method also we take the weighted average. In this method we give higher importance or higher weight to the latest period value, and the weights of previous periods decline exponentially. So let us understand this one in more detail. So we know that if we have a number 8 to the power 2, this is known as the exponent, and this is the base. So what this means is that 8, that is the base, has to be multiplied by itself 2 times. So this is equal to 8 multiplied by 8. Now if we have a to the power 3, then this means that 8 has to be multiplied by itself 3 times. So 8 multiplied by 8 multiplied by 8. So in the exponential smoothing method, the weight of the previous periods decline exponentially, and that is why the name is exponential smoothing method. So in this method, each increment in the past data is decreased by 1 minus alpha, and alpha is known as the smoothing constant. So if the most recent weight is alpha 1 minus alpha to the power 0, then the data, which is one time period older, will have the weight alpha, and we have to multiply this by 1 minus alpha. So 1 minus alpha to the power 1. Data for second time period will have a weight of alpha, again multiply 1 minus alpha, so 1 minus alpha to the power 2. And data 3 time periods older will have the weight alpha 1 minus alpha to the power 3. Now alpha has to be between 0 and 1. So let's take the value of alpha as 0.2. So alpha is 0.2. So then the values that we get for these weights is 0.2, 0.16, 0.128 and 0.1024. So you can see how the value is declining. So we saw one similarity, which is the value of alpha is between 0 and 1 for exponential smoothing, and the same thing applies for weighted average method, where the weight should be between 0 and 1. The second similarity is that the weight should total up to 1. So we will look at that validation after we have looked at the equation for calculating the forecast. So let us first put down the equation for calculating the forecast using the exponential smoothing method. So the forecast means ft, where t is the time period for which we are calculating the forecast, is equal to, so the first historical data will have the weight of alpha multiplied by 1 minus alpha to the power 0. So alpha 1 minus alpha to the power 0, and this is multiplied by the actual of the previous period. So a t minus 1, because the period for which we are calculating the forecast is t. So we have taken the actuals for t minus 1, plus now we have to multiply this weight by 1 minus alpha. So alpha multiplied by 1 minus alpha to the power 1, and this multiplied by the actuals for t minus 2 plus alpha multiplied by 1 minus alpha to the power 2 multiplied by the actuals of t minus 3, and so on. So here ft is equal to the forecast for period t. A t minus 1 is actual demand in the prior period, and alpha is the smoothing constant. So now let's evaluate this equation, that is 1 minus alpha to the power 0, and rewrite this equation. So ft is equal to, now 1 minus alpha to the power 0, anything to the power 0 is 1, so this becomes alpha multiplied by a t minus 1 plus alpha multiplied by 1 minus alpha, so alpha multiplied by 1 minus alpha a t minus 2 plus alpha 1 minus alpha square multiplied by a t minus 3, and so on. Now, as we had mentioned earlier, the sum of all the weights should be equal to 1. So let us go ahead and prove that. So the sum of the weights is alpha plus alpha 1 minus alpha plus alpha 1 minus alpha square plus alpha into 1 minus alpha cube, and so on. Now this can also be written as alpha taken as common and into bracket 1 plus 1 minus alpha plus 1 minus alpha square plus 1 minus alpha cube, and so on. Now we know that for the geometric progression, which is represented as 1 plus r square and so on to infinity, the sum is equal to 1 divided by 1 minus r. So if we apply this here, where r is equal to 1 minus alpha, so this will be equal to alpha and into bracket 1 divided by 1 minus, and r is 1 minus alpha, so this becomes 1 minus alpha. This is equal to alpha 1 divided by 1 minus 1 plus alpha, so this is equal to alpha, this 1 minus 1 is 0, so 1 divided by alpha, and this cancelled with each other, so this becomes 1. So hence the sum of all the weights is equal to 1. Now this was the expression that we got to calculate the forecast based on the exponential smoothing method. But this goes on till infinity and may be very difficult to calculate in reality. So let's try to simplify this. Now let's say that this is equation number 1. Now this is for period t. Let's put the expression for period t minus 1. So this will be equal to, again same alpha, but the previous period to t minus 1 will be t minus 2. So a multiplied by t minus 2 plus alpha into 1 minus alpha multiplied by a t minus 3 plus alpha 1 minus alpha square multiplied by a t minus 4 and so on. Let's say this is equation number 2. Now to equation number 2, let's multiply both sides of the equation with 1 minus alpha. So then what we'll get is 1 minus alpha multiplied by f t minus 1 is equal to alpha. Now here I'm multiplying this with 1 minus alpha. 1 minus alpha multiplied by a t minus 2 plus, now since we are multiplying the whole of right side with 1 minus alpha, every expression will get 1 minus alpha. So this will become 1 minus alpha square. So alpha multiplied by 1 minus alpha square a t minus 3 and so on. Let's call this as number 3. Now let's subtract three from 1. So this one we are subtracting from this one. So here we'll put everything as minus, 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 minus. So ft minus 1 minus alpha into ft minus 1. So let's put the left hand side first. So f t minus 1 minus alpha into f t minus 1. Now alpha into a t minus 1 is not here, so that will come in the output. Alpha multiplied by a t minus 1. Alpha into 1 minus alpha t minus 2, and here we have minus alpha into 1 minus alpha t minus 2. So this will get cancelled with this. Next is alpha 1 minus alpha square into a t minus 3 minus alpha into 1 minus alpha square a t minus 3. So this will get cancelled with this. And similarly, all the remaining parts of these two equations will get cancelled with each other. So finally, we get this equation. Now let's keep ft on one side and bring the remaining on the right hand side. So ft is equal to alpha a t minus 1 plus, so minus when we bring on the other side becomes plus, 1 minus alpha f t minus 1, or ft is equal to alpha a t minus 1 plus f t minus 1 minus alpha f t minus 1, or ft is equal to f t minus 1, this one here, plus, between this and this alpha is common, so we'll take alpha outside the bracket, and a t minus 1 minus f t minus 1. So what this means is forecast for period t, forecast for period t is equal to forecast for period t minus 1 plus alpha multiplied by, now for period t minus 1, the actuals minus the forecast. So initially you would have done a forecast for period t minus 1 and then eventually you got the actuals. So this is basically trying to find out what is the difference or what is the forecast error for period t minus 1. So alpha multiplied by forecast error in period t minus 1. So as you can see, in order to use the exponential smoothing method to find a forecast, all you need is three things: the most recent forecast, the actual demand that occurred in that forecasted period, and the smoothing constant. So if you have these three values, then you can calculate the forecast for the next period. Now this simplicity in finding out the forecast makes exponential smoothing a very commonly used technique. Also, in addition to this, the exponential smoothing method is very accurate in generating forecast. The formulation of the model is very easy. We don't need a lot of historical data, so we don't need to store a lot of information from the past. And the calculation is also very easy. Now in this calculation, one of the key components is the value of the smoothing constant, and this value is very important. We will look at how to find out the value for this constant to be used in calculation of forecast in a subsequent video. But right now, let us take up an example to understand the calculation for finding out the forecast using exponential smoothing method. So the example is, assume that the demand for a product is fairly stable and a smoothing constant of 0.05 is considered appropriate. Now assuming that last month's forecast was 1050 units and the actual demand turned out to be 1000 units, find the forecast for the next period. So the formula for finding the forecast using exponential smoothing method for period t is ft is equal to ft minus 1, that is a forecast value for the previous period, plus alpha, the smoothing constant, multiplied by the actuals for period t minus 1 minus the forecast for t minus 1. So here we have been given that alpha is 0.05, ft minus 1 is 1050 units, and the actuals for t minus 1 is 1000 units. So let's plug in the values here. So ft is equal to 1050 plus 0.05 multiplied by 1000 minus 1050 plus 0.05 multiplied by minus 50 1050. So this 0.05 multiplied by 50 is 2.5, and plus minus is minus, so minus 2.5. So this is equal to 1047.5 units. So this is the forecast for the next period using exponential smoothing method.